Fuzzy logic's been around a long time. It was first described in a paper in around 1965 by a man called Lotfi-Zadeh, and it's been around. It's been in widespread usage for decades, but there's still a lot of advances being made in it. Fuzzy logic is a way of dealing with uncertainties, which isn't something that computers do naturally, but something that humans deal with very well. So normally when we think of logic and when we think of reasoning about things, the way computers tend to deal with things and the way you might instantly think of dealing with things is true and false, 1 and 0. So for example, you might classify someone who's watching Computerphile as watching it, true, or not watching it, false. It's very simple, there is only one option or the other, we have no in between. That's not the way that the real world works, and that's not the way that humans work. So you can look out of your window now and you can say today's nice weather, or if you're in England it's likely not nice weather, but the definition of nice varies from person to person. With fuzzy logic, instead of just going with true and false, 1 and 0, we have a sliding scale. We have between that, we have what's called a degree of truth. So I can look out the window and say that today is kind of iffy, it's a bit sunny but there's some clouds, maybe it's 0.3 nice day or 0.7 nice day.
Is this about like the saying, there are no grey areas, it's either black or white?
Exactly, yeah, there are always grey areas. And the grey areas vary from person to person, which we'll come back to later. So logic is also very closely related to sets, and a set is a collection of things. So when we talk about something being true or false, we also talk about there being a set where something is true, and if it's not true, they're not in that set. So the set of nice weather, if I was going to describe nice weather, I would probably decide that I don't really like things too hot, so nice is when it's cold, but cold enough to not wear a jacket, but not too hot for me to feel uncomfortable. So that would be what we'd call the membership function. That gives a value for a certain thing. So if I check the temperature and I see that it's about 18 degrees, there's no wind, then that probably fits into a 1 on my niceness scale. If it's no clouds at all, there's no shade anywhere, it's 30 degrees, that probably is closer to a 0 on my scale. So you get nice sliding graphs. That gives us a way of dealing with uncertainty. So if we look at this example on the board. So this is kind of the typical example for fuzzy logic, which you see everywhere. This could be a shower controller. So with temperature, things don't just suddenly go from hot to cold. You have different scales. So what we'd have here is 3 of these membership functions that assign things to different values. So for example, at a low temperature, we know that it's cold. As the temperature goes up, it gets less cold, and then we start to see warm kicking in. So around, I don't know, we can decide this is probably about 15 degrees. I haven't put any actual values on here. So around this area, we now know that we're kind of mixing warm and cold. It's not strictly cold, it's not strictly warm. And then we have the same story with hot. So this gives us a way of dealing with the fact that the temperature of water isn't a strictly Boolean thing. It's not strictly true or false. If we look at the shower controller, we know that at some point, someone has decided this is now no longer cold. And this is where warm starts kicking in. So although we're dealing with uncertainties and we've got these membership functions that allow us to model them, you still have someone imposing their definition of that word onto it. Someone still needs to decide the values of the membership. And that's where things get very complicated. And when you're dealing with fuzzy expert systems, you often need to collect data from many sources, and you have to use various techniques to consolidate that data and to train the system to be as accurate as possible. Okay, so when we talk about a fuzzy expert system, we're basically talking about a fuzzy system where the membership functions and the values we're using have been fed in by experts in some domain area. So in our example, it would be experts in knowing what people like in their showers. They will decide at a certain temperature, this water is no longer cold, and it starts to get towards warm and pleasant. Fuzzy logic systems which use membership functions like this and have these fuzzy sets and have these degrees of truth are very widely used in all sorts of things you might not expect. When you set the setting on your washing machine, it doesn't just do it exactly that same way every time. It checks the load of the wash, it checks how dirty the water is after each cycle through. It does all sorts of things to decide exactly what temperature and exactly how fast to spin to make sure that it's as eco-efficient and giving as good a wash as possible. One of the most famous examples of a fuzzy logic system in use is the Sendai Railway in Japan. So this is a subway which is one of the first uses of fuzzy logic that actually measures the weight on the train, how fast it's going, suspension and all sorts of these things to make sure that it maintains a level and smooth travel. This diagram here is kind of showing a rough outline of a fuzzy logic system. We have an input which takes in crisp values. So these are things which aren't yet assigned a truth value. They're not in a fuzzy set, but then we fuzzify them. So we look at our membership functions and we apply some value to them. Then we have our fuzzy sets, and these go into our inference system. This is where all the magic happens. This is where we then start to reason. So we have a rule base, and a rule, if I quickly draw this on the board, so a rule has the form of an antecedent, then a consequent. If water is dirty, then, and then this will also be a fuzzy set. So water is dirty. This is a fuzzy set. So we're looking at our water, which will probably come from here, and we'll check it against the dirty membership function. So if we go back to our shower control example and think about that, we might say if water is warm, and we check how much it's warm. So say dirty, we had a membership function that some sensor was checking the water to see how dirty it was, and if it was pitch black and the sensor detected that it was very dirty, we could say that this is 1. So then we'd act on it in some way. So we then might say some other fuzzy set is a certain value. So we would say then spin very fast, or add detergent, or do another rinse cycle, any number of actions. And that gets on to the next point. So we actually have a rule base. There's multiple rules for different membership functions, for different actions, different outputs. And we run all of these rules through them, and then we combine them in this inference engine. This is what the inference engine does. It takes these rules, it applies the fuzzy sets to them, and it combines them to come up with some output, some decided action. This decided action is in the form of fuzzy sets. It then gets defuzzified because computers, as I mentioned earlier, they deal in certainties, they deal in true and falses, they deal in zeros and ones. We need to defuzzify them to something that the system can use. So we defuzzify it and we get crisp values as output. So that's some action. So go back to the washing machine, we take in some measurements of the water temperature and the water and how dirty the water is. We apply those measurements to our fuzzy sets, so we know some information about, so we have some fuzzy information, some true values about how hot and how dirty the water is. We then check those against our rule bases, and we decide on some actions. We decide how fast it should spin, how much water should be in the next rinse cycle, how much detergent we should mix in. We remove the fuzziness from that, and we give a crisp value as output, and then that action is undertaken by the system.
How does it work when it's not using fuzzy logic?
We'd probably end up taking our measurements, our crisp values, and instead applying an awful lot of if statements to them. So I don't know, if I rub this out and I don't know, if temp is less than 30 and dirt is greater than 6, do rinse cycle, or something like this. And you'd have to do this over and over again. Once we have all these rules built up that build on this, it looks very similar to our rule base, but the difference here is that because we're describing these here and we haven't done anything with this before, we're describing these conditions here and we haven't done anything with these values before, it's almost as if we're defining our membership function in the conditions, and it's a much less concise way of dealing with things. It's not as easily maintainable and changeable in code. It's just a bit messy, to be honest. And if you wanted to, if you decided at some later date that your washing machine would be more efficient if you'd done a temperature value differently or a dirt value differently, it'd be much more hassle to go back through it and change it all, and the system would be much more maintainable. Whereas in this way, we don't have to change the rule itself, we just change our definition of dirty. Our use of it is somewhat hypocritical in that we don't deal with all uncertainties. Our measurements might be uncertain, our definitions might be uncertain. So there's continuing advancements in describing these uncertainties better. But the big problem is once you start dealing with more uncertainties, the computational demands start to really build up. And that's the current area that is being tackled, as well as there's numerous areas. It's a very heavily researched topic, and it actually has probably one of the largest abundance of published papers for any individual topic.
You're trying to access this bit of memory, but that's not your memory. That doesn't belong to this program.
There's a little program which I've written already.
It's not happening, and so the operator.
Anyone which is familiar with BASIC will understand all of that.